Now let's try to make an exponential smoothing. Again, we copy the data, Control C, and we put it into a new sheet. Call that one EXP, exponential smoothing. And we just put our data in here in thousands. Then we want an alpha value, and let's call that one 0.3 for starters. The formula here is basically the alpha, which we're going to log, multiplied by the demand for the previous period, plus 1 minus the alpha value, so 70% weight on the forecast for the previous period, i.e. here we say 30% value goes to the demand last period and 70% goes to the forecast for the previous period. And it starts off slow, but it will soon pick up, don't worry. And we're just going to copy it all the way down here, like this. And maybe I should remember to lock this cell here, like this, that it hopefully should be easier to copy it all the way down, like this. Here we are, we're going to make a few like this. Again, it takes a little while to warm up if we have a look at it. Try to insert a line plot like here. We see that the series takes a little while to warm up. We don't want that. So what we're going to do is we're going to seed it. We're simply going to say that we take the demand, first demand in here, and we can see it start off very nicely. This first dip is from the start. So let's have a nicer plot like this. Just insert and a line plot. Here we are. Now it's easier to see what happens if I remove the seed. There you are. It takes a while to warm up and then it's there. So let's just seed it. There we are. Now we can try to change the smoothing value. Let's say 0.5 and see what happens. We can see that changes, maybe it fits better, maybe it fits less. We're going to find out shortly. So go back to 0.3. Now we're going to look at the residuals, the res, which is basically just what we see minus what we predict. And then we're going to copy that one all the way down. Here we are. And we're going to have a look at the MAD. Again, that's the absolute value of this one. And we're going to copy that one all the way down. And we're going to take again, I don't want all these like this, it's better. And we want the residual squared, which is of course just the residuals here, squared. Again, copy it all the way down. Now we can have a look at the sum of the residuals. And we can have a look at the sum of the MAD. We removed the first one because we use one for prediction, so we're going to divide by 43 to get the average. And here we're going to take a sum of all this. It's going to be the sum of all the previous. And we're going to square that one. And we're going to take, no, we're not going to take, we're going to divide it by 41, of course. And then we're going to take the square root of it. Okay, going to take the square root of it, like this. Going to make it yellow. We're going to copy this up here so we can have a look at what happens when we change. This is of course just cell, this cell here, and we can copy it all the way over here like this. Now we got the cells. We see that there's a definitely a skewedness. We are under forecasting, because when it's positive we are under forecasting. The average error is 2.9 and this average squared error is 3.7. Let's have a look at the residuals. We're going to make a plot of the residuals also. Here are the residuals. Let's have a look at plot of the residuals. This is what the residual plot looks like. So now we got the line plot. We can make it a little bit bigger. And we got the residual plot here. And we got these numbers here. Now let's see if we can minimize it. Let's try to say 0.5, see what happens. We're just going to take this baseline here, Control C, and insert the values. Just straight values here. These are the straight values for the 0.3. So let's have a baseline. Let's see what happens if we say 0.5. This definitely goes down. Squared says the same, mad gets a little up, but the total goes down. Let's see what happened with the line. It's very nicely over here. And this is our residual looks like. Fine, let's go for 0.7, see what happens. Now it's 3.9, 3.2, definitely going up, this one going down. So what happens if we say 0.1? This goes bigger, so 0.4. There we are. 2.9, 3.7, this is the same, this is smaller. So maybe we should go for 0.4. 0.3, what about 0.35? Nope. 0.45. 38.29. So 0.45 looks like a little bit better than 0.4. So 0.45. If we're using an alpha level of 0.45, we're looking at the best result. So this is what we're going to do with the here is we're going to settle in for an alpha of 0.45 in our exponential smoothing.